To continue our talk in statistics, we're going to move on to scatter plots. Scatter plots are just a graph with a whole bunch of different points plotted that show a relationship between two sets of data. In this scatter plot, we have two sets of data, a person's height and people's weight, and we have our points scattered around. Now, according to this one, it's pretty safe to say that the taller the person is, the more they're going to weigh. And here's another example. So a local ice cream truck keeps track of how much ice cream they sell versus the noon temperature that day, and here is their recordings the last 12 days. So we have our two sets of data, the temperature and the ice cream sales. Then we took this graph and plotted onto this scatter plot, and we can make a pretty good assumption the hotter it is, the more they're selling. It's not always true, but in most cases, it's pretty true. So after you plot your points in your scatter plot, they're going to be something similar to these graphs. It'll be one or the other. And that's, we want to look at the correlation. Correlation describes the relation between the two sets of data. So either your correlation is positive. If it is positive, that means your values, both your sets of data are increasing together. If your correlation is negative, that means one value is decreasing while the other value is increasing. Okay, so let's look at our data here. So this is a perfect positive correlation. So you see your points are going up. They're pretty much in a straight line. A high positive correlation means your values are still going up, but they're kind of a little bit more spread out. Low positive correlations, your values are still going up. They're still increasing together. So as you go up on your x-axis, your dots are still getting higher. Difference with this one compared to the high positive and the low positive, the difference is they're more spread out here. Now you can have graphs, scatter plots that have no correlation. You really couldn't put a line in here to find what the best fit would be. Low negative correlation, so it means that as one value is increasing, the other is decreasing. So if you look, I start out high with my y's, but the farther I go on my x-axis, it gets lower. My y values get lower. And also they're spread out, so that's why it's a low correlation. All right, this is a high negative correlation. That means my dots are pretty close together. My y values are starting out high, and my x's are getting smaller. Or my y's are getting smaller as my x's get bigger. And perfect negative correlations, I have pretty much a straight line here. And my y start out big and get small as my x's start out small and get big. Right. When we have scatter plots, we're going to concentrate on doing what's called the line of best fit. Right. The line of best fit is just a straight line that represents the data on a scatter plot. The line of best fit can go through some of your points, it can go through all of them, or it can go through none of them. It's kind of up to you what the line of best fit is. Right. So after you choose what you think the line of best fit is, we're going to find the slope of that line by taking 2 points, subtracting your y's, subtracting your x's, and then we're going to plug them into the point slope formula. Right. The point slope formula is y minus y1, where y is just a variable, it won't change, and y1 is any point on that graph. M is your slope, x is just another variable, you leave it alone, and x1 is the x value that goes with your y value. So you pick any point on the graph and plug it into this formula with your slope. Right, the following table lists the number of population of a city from the year 1960 to 1995. We're going to sketch a scatter plot and then draw the line of best fit. And then we're going to have a couple questions we need to answer after that. Right, so if you notice, I have my x-axis labeled as the year. I have my y-axis labeled as the population. I go up by 5s on my x-axis, I go up by 3s on my y. So I need to take this table, and I want to plot the points. So my first point would be 1960. There were 15,000 people. So 1960, I want to point on 15. 1964, there were 19.5. So that's going to be, say, around in there. 1971, there were 21,000 people. So we'll put a dot about right there. 76, they were 24,000. So it's going to go about there. In 1982, there were 27. So it's about there. 1985, there were 30. So we're going to go there. And 1993, there were 33,000. And in 1995, there were 37.5. So that's going to go off my graph a little bit and go up in there. Okay, so now you want to draw the line of best fit. Now this doesn't have to be the same for everyone. You want to try to get as many dots on the line or get the same amount of dots above the line that you have below it. So I'm going to draw my line about through here. And that looks like it's pretty solid. Okay, so I want to pick 2 points on this line and find this so I can find this slope. So I'm going to choose, let's go with this point because it looks like it crosses pretty evenly. So that would be 1990 and 33,000. So my x is 1990, my y is 33. Then I'm going to choose, where's another good one? How about this one right here? So that's 1965 and 18,000. So 1965, 18. I want to find the slope of these two lines. Slope is my y value minus my y value over my x value minus my x value. So I'm going to choose to do my first point on top first. So it'd be 33 minus 18 over, and then 1990 over 1965. So when I do 33 minus 18, I'm going to get 15. 1990 minus 1965 is 25. Then we can reduce this to 3 over 5. So the slope of that line is 3 over 5. I need to plug it into my point slope formula. So remember, point slope was y minus y1 is equal to m times x minus x1. Y and x are just variables. We're going to take the y1 and replace it with one of these points, we'll choose 33. We're going to take the x1 and replace it with this 1990. We'll take the m and replace it with 3 over 5. Okay, so we'd have y minus y1 is 33 is equal to 3 over 5 x minus 1990. Okay, so now let's solve for y to get it in slope-intercept form. When I solve for y, the first thing I want to do, I want to distribute. So I would have y minus 33 is equal to 3 over 5x. Then when I do 3 over 5 times negative 1990, I get negative 1,194. Okay, so I need to move the 33. So add 33 to both sides. And negative 1,194 plus 33 is negative 1,161. So that is the equation for my best line of fit. Alright, so we are going to use that equation to answer a couple questions. Alright, first of all, what type of correlation does this graph has? If you look at the points, they're very close together, so that would be a high correlation. and it is going up, so it would be a high positive correlation. Alright, it wants us to predict the population in the year 1970. So if you look at your graph, the x-axis stood for the year. So if we want to know what the y-axis stood for the amount of population. So if we want to take our formula, our equation we came up with, and we want to find out what the population was, so what y is when we are in the year 1970, we want to take x and replace it with 1970. So we would do y is equal to 3/5 times 1970 minus 1161. So the first thing we're going to do is do 3/5 times 1970, which would give us 1182 minus 1161. And 1182 minus 1161 will give us 21. So that would tell us there'd be about 21,000 people in 1971. Now that's approximate, it's not exact. And then it wants us to predict what the population would be in year 2015. So we want to kind of do the same thing here. We're going to take x and you want to replace it with 2015. When we do 3/5 times 2015, we get 1,209, and 1,209 minus 1,161, you get 48. So there'd be about 48,000 people in this city in the year 2015.